based off of numerical calculations. And the problem is, as stated, that I have a ball with no mass from at rest falling to the ground from 3 meters high. And since my ball has no mass, my acceleration is going to be due from gravity, and gravity is 9.8. Since my ball is falling down, I have my gravity set at a negative, so my whole setup is based off of negative. So when I come to my final answer, well, my final velocity, which is v17, and my final point, which is point negative 5332, I end up, my final y position ended up giving me 3.2, so I got it pretty close to the 3 meter height. And my final velocity ended up being negative 3.136, and I use my final velocity with this kinematics equation 3.1336 equals my v initial, which was 0, plus my acceleration, which is 9.8 times time. And since I'm solving for time, I divided my 3.136 by 9.8 to get time is equal to 0.32. And that also comes close to my 17 positions, 17 different data points times every 0.02 seconds intervals gave me 0.34. So my time ended up coming pretty close, as well as my my y being close to my height. So I used my initial givens, which was my initial velocity, which was 0, my initial change in time was 0.02 seconds. I used that as every interval. My y is 3 to represent the height, and my initial time is 0. And I used v2 equals v1 plus acceleration times change in time, and also use the formula y2 equals y1 plus v2 times change in time. And I simply just took my initial, plus the acceleration times the change in time to get my v2, and I plugged in my v2 from here to here. And since my initial was 0, I didn't have to add anything. I just multiplied my v2 times my change in time to get my y2. And to get my next set of data points, I changed that from v3 to equal to v2, and plus acceleration times change in time. And my v2 come from here, which is negative 0.196 plus acceleration times change in time to get my v3. And to find my y3, I have to do y3 equals y2 plus v3 change in time. I took my y2 from here, plugged that here, my v3 from here, plugged that here, times change in time to get my y3. So I continued this from v4, y4, y5, all the way until I ended up getting to v17 and y17. And these were my final data points that got me my last bit of data to plug all that into here, into this formula, which of course is a kinematics equation. And that's how I end up getting close to the getting the time as 0.32, close to the 17 positions for the 0.02 intervals to 0.34. And of course I just added all my y positions up. That's how I get the 3.2, which is close to my 3 meter height. So this is my numerical calculation.